computing.
Corey's got the floor.
Yeah, cool. Yep, cool. So this next one is coming to us from New Atlas, and it just says quantum computing hits the desktop. No cryo cooling required. So okay, so again, I'll just preface talking about this article. I'm not going to go into all of like the science of how the quantum computing actually specifically works. I'm really just trying to cover the article and really make the video, this particular segment, accessible to as many people as possible. So just to go through basically here though. So the idea, if you've been following quantum computing in any way, shape, or form, you may or may not know, but you may know that some of the components of the quantum computer need to be quite cold, and absolute zero, as close to absolute zero as possible, and that's a temperature, really cold temperature. The idea is that if you cool things down, all of the atoms and all the atoms slow down. They vibrate less and less. The movement is less and less. And what you can do with that is where they need to get some of the components of the quantum computer down so they vibrate as little as possible or almost none at all, with absolute zero. And that's because they need to keep some of these qubits, some of the components on the computer, from having any coherence or loss of coherence, so that they can use them to do calculations. So one of the big hurdles there, as I just explained, is having things cool down to absolute zero, which kind of obviously limits, having to bring your quantum computer home, at least in its current form, to anywhere besides labs or places that are specifically made for such a thing. But anyway, this company here, it's an Australian-German company, and they are saying that they've kind of changed how they're doing the idea of qubits themselves, and they can basically do them at room temperature.
Nice.
Which is pretty crazy. So you got to go have a look at their website, and of course maybe look through the article too. Obviously it's down below. But the idea is, if you go to the website, they're saying basically what they're trying to do is they're using diamonds to act as the qubit.
Sounds expensive.
And by doing certain things with that, they can basically do them at room temperature. And they're working on scaling it up in terms of how many qubits you can do. But there's ideas that they'll also not just have the quantum computer itself, but they'll have, maybe they can build this thing into what they're calling, let me get it so I don't say it wrong, quantum accelerators. And the idea of that is it'll be their device, but in a form factor and size of like a big graphics card.
That's pretty cool.
So you could possibly buy, or if you're in the field, and obviously this isn't going to be cheap anyway, but you'd be able to get this and put it in your maybe workstation at work, or your computer if you have your own business, depending on what you're doing with it. And then the types of calculations that would benefit from classical computing, meaning the computer you have now, you could do that. But something that would benefit from using their product, their quantum accelerator, you could do that with that piece of hardware, in the same device, if you had such a thing. So that's kind of the real quick rundown. And I would say go through here and read all the fine details.
There's a white paper. There's a white paper on their website, by the way.
Yeah, there's more stuff about it. But again, just kind of kicking off the conversation, Mike, what do you think about it?
First, can I game with it? That's what I want to know. Second is, when is Linus Tech Tips going to get his hands on it and do a benchmark and find out how it really performs? And lastly, look, obviously unverified. They say it's for sale, but it's unverified, the fact that they can do this at room temperature. Interested to know what the price would be, right? Obviously,
sure,
I'm assuming it's not going to be cheap, because if this does, and they can prove that this thing does what they want it to do, obviously it's great, because this is the way technology goes, right? Starts room scale. The old computer started transistors, before transistors.
That's true, yeah.
Started with old vacuum tubes, and we eventually made our way down in size. Same thing with old televisions. Old televisions used to be the size of furniture. Right? And now, obviously, it makes its way down. And it sounds like to me that the way that they're imposing this technology looks like, at the very least, it's going to be some sort of rack-based system where you plug in through Ethernet, and then you get your quantum, brilliance computing through that. Now, here's the only thing that I see, and that is basically they say, their hardware, and I hope, I'm just throwing it out there, that when we look at this picture, it has a laptop plugged in through an Ethernet hub, which is basically going back to the quantum brilliance, which looks like their rack server box. I hope that we have fast enough speeds on both sides of that Ethernet that can actually deliver what is basically the quantum brilliance calculations at speed. Unless we're talking about this is going to be more of a mainframe style, kind of number cruncher, and then you're going to get your, your quantum Brilliance efforts later on, and you just have to read what comes off the the side. I don't know what their applications are going to be yet.
Yeah.
But that's just me.
That was kind of what I was thinking when you were talking about that, was you might give the job to the wherever it's
Mhm.
computed, wherever they actually have their processors or their quantum accelerators. You'd pass the job to that device, and it would do whatever it's got to do with it, and then it would pass you the solution. You know what I mean?
Which would be cool.
So I don't know, but I mean, yeah, we'll see.
I mean, so look, now the other part of it is if they do get this down, well, here, will it be as hard to get as a 3080? And
Oh,
yeah,
geez, wow, look
yeah,
look
look
at
at
you, straight knife in the heart there. I don't know. I don't know. I mean, we're obviously kind of joking, but maybe not. I mean, if they really work, then they're going to be in high demand. Let's
well,
just
and
say.
look, what the other thing that I want to know is what's the current chip shortage?
So, I mean, they know
Yeah,
they
and
work.
what's the
So,
other thing that I want to know is what's the current chip shortage doing currently for them? Is that creating any other problems that they might see for being able to deliver this, right? And I want to know the last thing is obviously what's the price, right? What are you going to pay for this thing?
well, yeah, of
So,
course. I mean,
you know what? Maybe we should contact them, reach out, and be like, "Hey, we're just curious. What's the price of a unit?" And they have a little contact us here at the top of their website. So I think I might do that.
yeah, I mean, totally can. Just say, hey, reach out. We're just interested in tech, and we got a channel, and hey, can we get some
Yeah,
more
and
info?
also here, also on their website, they do have a picture of what's called the quantum computer hardware, and then they have the quantum accelerator, which looks like to be just like you spoke about. It looks to be broken down into the size of basically a video card, right? And I would assume
Mhm.
that whatever bus that sits on is going to be, I would assume, a proprietary bus that they're going to have massive speeds that can give you the acceleration properties at least so that it dumps in. Because the other thing is, look, if this thing's going to be doing massive calculations, right, and it's got masses of data, your bus speed is going to be important as to how long it takes you to read that data. Because it'd be great, it's massive chunk of data, but then it takes like an hour for you to access it because, well, there's no pipe big enough for you to even view it, right? That'd be interesting too.
Yeah, I guess it depends what you're asking it to
Don't
do.
know.
Obviously, using the medical field and things like that, where this kind of thing would be
Yeah.
useful. But we'll see. We can reach out and maybe get some more
Yeah,
info for
there
you
you go.
guys.
All right. Well, cool. Awesome.
Yep. So, yep. Thanks. You know the drill. Like, share, subscribe. We very much appreciate it. Hit the bell down there. Notified when we get new videos out, and we can update you on some of these topics. Space, aviation. You guys know what we kind of cover. So, thanks so
Thank
much.
you so much. Yeah.